In this video, I explain question 35 from practice final exam. Okay, so let's read this question. Okay, so you're given with a table. Okay, so you go, oh, this is the same substance, but right, should should we pay attention? One's gas, one's liquid. Okay, and let's see how we can use those information. Okay, and then saying vaporization of it. Okay, you go vaporization. What does that mean? That means it's going from liquid to gas phase. Then it's asking if it's going to be spontaneous at what kind of temperature. It's not even asking you to solve the actual value. Then you go, well, how do I use these numbers here? Okay, so then of course you have to see what kind of situation you're dealing with over here. If you do remember from the lecture, I summarized into a table and I was talking about, right? If you remember, I'm not gonna do the whole thing, right? But if you please go back to your note, right? We'll talk about what the sign will be, and then just say if it's negative, positive, right? This is going to be negative, that will be spontaneous, right? So that's the table I'm referring to, okay? And then we fill out the whole table, okay? So depends on what the sign you have, right? It's negative, negative, positive, top positive, and what that will be, okay? So that's the table I'm talking about, okay? So then this is what you wanted to know. You wanted to know what are the sign for dot H and dot S, then you will be able to tell if it's going to be spontaneous at all temperature or, you know, non at all temperatures it's just going to be non-spontaneous or what the situation needs to be. Okay, so you need to figure out what's the sign for delta H and delta S. Then the way to calculate is right from these values. Okay, then you go, then how? Okay, so right, if we're looking for from liquid to gas, right, we are looking for a change. Okay, so the change of delta H for this process, how are we gonna do? We're gonna use the gas phase minus subtract the liquid phase for delta H, right? That's final minus initial, right? The final state will be gas. So we're gonna use the final, okay? And that's kilojoule per mole minus initial is equal 4.2 kilojoule per mole. Okay, so you do this calculation, you go, well, really you don't need the actual to do the calculation, right? You can do opposite. You go, okay, so this is gonna be positive. But of course, since I already did that, let's just have the value calculated. That's positive 41. So dot H will be positive, right? Okay, so then you go, okay, so that could be the one of those situations. Then we still need to calculate dot S. Okay, so let's see the same logic, right? So you can use gas phase minus initial. Okay, so which will be liquid. So you're gonna go 354.9. That's joule mole times K minus 221.9 joule mole times K. Okay, so you do this calculation, you get 133 joule per K. Okay, so as I always say, right, units. Okay, I'm gonna actually convert it, so this is easier for me to explain more later. Okay, so this is what we have. Okay, so that's dot S equal data is also positive. Okay, and then of course you have your notes. You already know what the conclusion should be, and then actually the answer will be C. Okay, but in terms of really understand this concept, you should think about this, right? Okay, so you go, how do I think about this? We need to use this equation. Delta G, I'm actually going to use a different color. Okay, so delta G equals delta H minus T delta S, right? Okay, so this is really how the enthalpy and entropy will affect spontaneity, right? By using this equation. Okay, so then once we know delta H is positive 41 kilojoule per mole, right? T delta S is 0.133 kilojoule mole times K. Right, you go, what do I want? How do I see it's going to be spontaneous or not, right? As we mentioned, delta G needs to be what? Needs to be smaller than 0. That means that it's going to be spontaneous. Then we are looking into what kind of temperature we need for this relationship to be smaller than 0, okay? Then of course, from this point, you could do a calculation, but then not necessarily, right? You go, I need it to be smaller than 0. And then let's look at the values we have. We have a 40, 41. We have a 0.133. So that means you needed this 0.133 times the number, the, the product from here, this value, needs to be bigger than 41. Therefore, then this value could be smaller than 0, right? So that t needs to be high, needs to be a large value. Otherwise, it wouldn't happen that way, right? Okay, so this is just use a little number to see actually mathematical how this works. And actually, I already explained this during the lecture. But anyway, so this comes to this conclusion right here. That'll be spontaneous at high temperature and non-spontaneous at low temperature. Just say if it's only a very low number, I don't know, 2K. I'm just making things up, right? If it's 2K, look, when you multiply, that's what? 0.266 kilojoule. That's way smaller than 41. So it's going to be non-spontaneous because when you use 41, only minus 0.266 is going to be way bigger than 0, right? So it's not going to be spontaneous, okay? So this is just how you can use the information, do some calculation, but not really. This is not a it's not a calculation question. It's a conceptual question. Okay, so this is how you see this type of question. And then hopefully this is helpful. And thank you for listening.